Good evening, everyone, especially to you, sir. Good evening. And to all my classmates, good evening to you, madam, sir. At this moment, I will be going to discuss the Kruskal Wallis test. And by the way, I'm your presenter, Mr. Sanajan C. Moreno. And I'm going to discuss it in a basic, okay, flow of procedure. And please allow me to proceed. And I do apologize for if I'm not going to make it a little bit discussed in a very excellent way since I am not really good uh, on statistics topics. But I will try my best, sir and ma'am, to discuss this. And objectives for this evening, at the end of the presentation, you will be able to, number one, comprehend the meaning and purpose of a Kruskal Wallis test. Second, examine the procedure and steps of Kruskal Wallis test. And third, grasp the process of calculation and getting the result for the hypothesis on the data. Here we have meaning and definitions of what would be the Kruskal Wallis test all about. The Kruskal Wallis test is a non-parametric procedure that can be used to compare more than two populations in a completely randomized design. The Kruskal Wallis test was promulgated or um, showed last 1952 and 1953 by Kruskal and Wallis. It is the non-parametric equivalent of a one-way ANOVA and is used for testing whether samples originate from the same distribution. This test is basically an extension of the Wilcoxon-Mann-Whitney two-sample test for more than two independent samples. And in other words, the Kruskal-Wallis test is also called the H test. At this time, I am only actually um, be glad on studying this topic. Okay, let's proceed. Kruskal Wallis test is basically a version of the independent measures one way ANOVA that can be performed on ordinal data, rank data. So for us to be able to comprehend more on how it will going to be performed, let's have an example, by the way. It is like an ordinal data is displayed on the table. If you could see in the table, it is an ordinal data sample. So the question is there a difference between groups 1, 2, and 3 using an alpha, which is 0.05? So we have that three groups of numbers uh, consist of six numbers each group. Okay, so let's proceed. In order for us to calculate and perform and how we are going to calculate the Kruskal-Wallis procedure, let's remember these 7 steps of Kruskal-Wallis test, okay, which is the number one, define the null and alternative hypothesis. Second, we're going to state the alpha. Third, calculate degrees of freedom. Fourth, the state decision rule, and the fifth, calculate test statistics. Sixth, state results, and the last would be we have to state our conclusion. Okay, so let's proceed. First, we have to define first the null and alternative hypothesis. So based on the three groups, which is the table for the sample, our hypothesis one will be there is no difference between treatments. Our second hypothesis will be there is a difference between treatments. So next, second is you have to state our alpha, which is it was only already mentioned a while ago that our alpha is 0.05. And then next, we have to calculate degrees of freedom. So our degrees of freedom will be a formula like this one, df equal to k minus 1 will be our formula, and k represents our group of numbers. So we have three, since we have three groups, it will be df equals to 3 minus 1, and the result will be 2. All right, and here we have to state our decision rule. If you could see in the table, it is the table that as usually used by Kruskal Wallis test. It is the k-square table. So in this part, so we have to state our decision rule. So if x squared is greater than 5.99, so if you could see on the green number on the table, the why is it circle level on the number 2 for df, since our result earlier is 2 for the degrees of freedom, and since our base for the alpha is 0.05, so that's why the intersection for that one is the 5.99147. So that would be our baseline. So if the x squared is greater than 5.99, then we will reject the null hypothesis. But if the x squared is less than 5.99, then we will not reject the null hypothesis. Now let's see, and let's proceed. Okay. So here we have to calculate our test statistics. So the table on the on the left part will be the group 1, group 2, and group 3 will be our um, ordinal data, the first mentioned and the first, um, I mean on the example. Okay, so on the right side we have the original score with the rank. Okay, since this would be an ordinal rank or an ordinal data, we have to um, rank it from 1 to 18. Why is it 1 to 18? Because the numbers in group 1 are 6. In group 2, there are 6 also numbers, and same with the group 3. Going to add that one, it will be 18. 6 will be 18. That's why we have rank number 1 to 18. And then for the original score, from we have to rank the numbers from the table from the lowest to the highest. So since in the table group 1, 2, and 3, the lowest number would be 2. Okay, so that's why our rank 1 would be 2. And our highest rank, which is the highest number in the groups number, would be 36. So if you could notice that our rank number 1 would be 2, and our rank 18 will be 36, since 36 is the greatest or the largest number among the numbers of the three groups. Okay, so in the next step, we will now going to use the new data uh, numbers from this rank. We will no longer use the group 1, 2, and 3 numbers, since we are using ordinal data. So let's proceed. And we have to calculate test statistics. So if you could notice here, group 1, group 2, and group 3, the numbers below are different now. Why? Because we are using a rank data number based on um, getting the number from ranking, which is on the old table. So this would be our new table. So if you could notice, the numbers on group 1 are different, same in the group 2 and same in the group 3. So we'll now base our calculation on this table. Below would be the formula for in getting or calculating test statistics. We have H is equal to 12 over n times n plus 1 times the sum of t1 squared over n um, will be subtracted to 3 um, times n plus 1. So it's look confusing, but we will see it later on. How we're going to replace this symbols in our numbers from the table. So here, um, you could notice our h will be is equal to 12, then over 18 times 18 plus 1. Why 18? Because our n would be uh, 18, since our rank is 1 to 18. Okay, so 18, our n would be equal to 18. So that's why our n there would be replaced with 18. And the sum of t1 squared, which is the sum of the numbers from group 1, group 2, and group 3. So if you could see there, we have the table with the additional symbol of t and n. The t1, the t group 1 would be 39, which is the sum of all the 6 numbers. as well as the group 2, group 3 also. So there we could see the T1 is 39, the T2 is 65, and the T3 is 67 squared, which has we're going to add those three numbers with the denominator of 6. Why 6? Because our n, the small n, is represents the 6 numbers of each group. So here, 1, 2, 3, 4, 5, 6. So every group, there are 6 numbers. That's why our n, small n, is always, is 6, including the group 2 and the group 3. So there, you could notice that the denominator would be 6, 6, and 6 times minus 3 times, which is our big N, which is the numbers of our rank, which is 18 plus 1 is equal to, this would be our solution, our result for calculating the statistics, 2.85, 2.854. So that would be our resolution, the result of our calculation for the test statistics. So now let's proceed. We have to state our results. So if we're going to go back to our decision rule, that if x squared is greater than 5.99, then we will reject the null hypothesis. But if x squared is less than 5.99, then we will not reject the null hypothesis. So since the result of our h is equal to 2.854, so I'm going to see to base that on our baseline is 5.99. 2.854 is less than 5.99. So therefore, we will not not reject the null hypothesis since 2.854 is less than 5.99. Okay, so in our conclusion, since this is the last step for the procedure of Kruskal Wallis test, our conclusion is there is no significant difference among the three groups, which is age is equal to 2.854 times 2, and n is equal to 18, which is less than 5, 0.05. So the conclusion is there is no significant difference among the three groups. Okay, so I hope that you learned something, even a small thing, with regards to Kruskal Wallis test and how we are going to perform and calculate the calculations of test statistics using Kruskal Wallis test. Thank you everyone for listening, and thank you for your time for watching this video. And finally, sir, thank you so much for allowing me to discuss. I'm really sorry if I'm not really good in explaining those statistics and procedures, but I am doing my best. And also to you, to my classmates, ma'am and sir, thank you very much for your time for watching this video. Thank you once again, and good evening, everyone.